Okay, for this problem, we're going to talk about spectrum representation. And basically, a spectrum graphically represents the frequency content of a signal. So we want to know what frequencies are present, how much of each frequency, and what's the phase of each frequency. All right, so we have a signal Vn of t, where this would be your DC content. So omega is 0 radians per second. This one here would be omega is 10 radians per second. And this one would be omega is 30 radians per second. Okay, now each of these signals has a magnitude and a phase. So recall when we're looking at phasors, right, we can represent the DC component as 6 at 0 degrees. The next component is 3 at 45 degrees. And the next component is negative 2 at 60 degrees. So now we can create the magnitude spectrum. All right. So for each of the frequencies represented, we had 0, we had 10, and we had 30. So the magnitude, which is Vn, okay, we have 6. From the DC component, we have 3, and we have 2. Okay, so now we want to look at the phase, and the phase will be the angles associated with each of our phasors. Okay, so again, we have 0 degrees, we have 45 degrees, and we have 60 degrees. Okay, so again, this is the magnitude and the phase for this signal representation. Okay.